really do two major things in this section. We're going to verify identities. So it's kind of like a proof. It's not really a technical mathematical proof, but it's the idea of verifying that this identity is correct. The other thing is simplification. In calculus, you actually use trig a lot to rearrange and simplify expressions a lot when you do derivatives or integrals. So the first thing I'm going to do is, we've already talked about all these identities right here. These are ones that you want to have memorized. I won't ever give you these identities because they're all the fundamental things that are really important. So what we're going to do is we're just going to use identities to see if we can simplify this expression. Okay, and this is a real common thing you'll do in calculus. So what I'm going to do is I'm just going to look at identities, and you have to just try stuff on this stuff. Okay, so if I look at a cotangent, one possible identity I can do is I can do cosine over sine. If I look at a cosecant, one possibility that I could do on that is the cosecant is 1 over sine. You get better with knowing what to use with experience, but at this level, you have to be willing to just try something, okay? Seriously. So what I'm going to have you do is the cotangent, just replace that with cosine x over sine x, use that identity, and then the cosecant, change that to 1 over sine x like that. Okay, so I'm just applying those identities. Now we're going to simplify this and see what happens. Now, you can do a shortcut on this if you want to. I mean, you can cross the signs out. I want to show you what basically is going on in this problem and just remind you what you're doing is cosine over sine divided by 1 over sine x. So when you divide fractions, you do the reciprocal of the second. So you get cosine x over sine x times sine x over 1. So this ends up basically simplifying down to cosine of x. Now you could bypass those last steps because I've shown you how to do this a lot of times. If you have a complex fraction and those denominators are the same, they cancel out anyway. So you get cosine of x like that. So again, what we're doing is using identities to see if we can simplify this trigonometric expression in some way. Okay? All right, next one, let's see. We have sine negative theta. Well, that's an even odd identity, so we can change that to negative sine theta. You have cosine negative theta. That's an even function, like we learned. So that's just cosine theta. And then tangent of negative theta, that's an odd function. So we can change that to negative tangent theta. Now you want to try to, do these problems without looking at these identities because you do want to get these things memorized. So the sine of theta, negative theta is negative sine theta. The cosine of negative theta is just cosine theta. It's an even function. And then the tangent of negative theta is negative tangent theta like that. Now we're going to try to take this and simplify this as far as we possibly can. So what I have then is I have a negative times a negative is a positive. So I'm going to write this as sine theta times cosine theta times tangent theta. We want to try maybe one other thing though, all right? Any suggestions for what I could maybe do with the tangent of theta? I mean, just as a useful identity, you only have a couple of choices. You could do 1 over cotangent theta, or you could do sine theta over cosine theta. That's the one you want to go with, right? Okay, so what you would do is you would have sine theta times cosine theta times sine theta over cosine theta, and that's just because it's going to cross out that cosine theta. So now you get sine times sine, which is sine squared theta. What you're trying to do on most of these problems is try to get it down to where you have just one trig function in your answer. Most of the problems are designed so that's what you do, okay? So that's the idea of simplifying on this, and that's an important skill for calculus. That's kind of the point behind this is you're going to be doing this kind of thing in higher level math class. All right, any questions so far? Okay, you guys with me okay? All right. Okay, let's do a couple more of these just on the next page. You get a little bit of practice in here on this. And again, kind of depends on how complex the expression is as to how complex the work is. So what I would look at on this one is Well, anytime you have like a cosine of a negative angle or something, you're probably going to automatically be thinking about even-odd identities. So this goes like this. Cosine of negative x is just cosine theta, and then the sine is negative sine theta. Okay, and again, if you have it memorized, the way I like the students to memorize this is the two even functions are cosine and secant, so they'll end up just being positive, and then all the rest are odd, so they're going to have that negative in front of the trig function. So basically, we're going to change the cosine of negative x to cosine of x. We're going to change sine of negative x to negative sine x. Then we still have the subtraction symbol, and then the cosine of negative x is cosine x over sine x. They're just doing what those identities tell you to do, okay? All right, well, let's see if we have any idea what I'd do next. Okay, these things are like a puzzle, okay? Anything you can do with a cosine over a sine? Is there an identity that has something to do with a cosine over a sine? Yeah, it's right here, okay? Cosine over sine is cotangent. Okay, that's it. And then once you get these things memorized, you'll do these a little faster. So anyway, this whole thing right here, it's a negative answer, so that's just negative cotangent of x minus cotangent of x like that. Okay, well, those are like terms, so -1 minus 1 is -2. So that should simplify down to -2 cotangent x. Okay, with practice, you get to where you start recognizing these things fast. Cosine over sine is cotangent, sine over cosine is tangent. Okay, once you get that down, it'll be pretty quick and easy. Okay, let's see. Next one, we want to kind of see what we can do on this. There's probably more than one way to go about looking at these problems too. Sometimes I look at it and kind of see if I can come up with a little easier way to do this. So here's what I'm going to do. And I think a lot of students, when they start this, would probably just immediately start substituting in for tangent and cosecant. One thing that you want to learn how to do is split these fractions up. So you could actually write this as 1 over cosecant of alpha plus cosine of alpha, tangent of alpha, cosecant of alpha all over cosecant of alpha. Okay, like that. So you can split it up. That's something you want to make sure you know how to do, is if the numerator has a plus or minus sign separating stuff, well, you can divide that fraction up. The benefit of doing this way is this. What's 1 over cosecant? Which trig function is the reciprocal of the cosecant? The sine is, okay? So here's the identity right here. You have 1 over cosecant is just equal to the sine. So what I'm going to do is I'm going to change this to sine of alpha. That's a little simpler. Okay, over here, notice that the cosecants divide out. Okay, so that's kind of nice. That's what I did. I looked at the original problem. I realized that I could get rid of the cosecant. Okay, then I'm left with cosine alpha times tangent of alpha like this. Okay, well, I would do one more thing. All right. What do you guys think? Tangent, what's a good thing to do with the tangent? You have two choices, 1 over cotangent or sine over cosine. Sine over cosine, that'll divide out that cosine there. There you go. So it's sine of alpha plus cosine of alpha times sine alpha over cosine alpha. That'll take out the cosine. So then you end up with sine plus sine. So a sine plus a sine is 2 sine. Those are just like terms. So the simplified answer on that would be 2 sine alpha like that then. Okay? By the way, there's more than one way to do this problem. I mean, that's probably how you would ultimately get there. But that to me was just what I saw as a pretty basic way to do that problem. Okay? All right? All right, let's see what happens on the next couple here. What I would probably do on this one is you probably need to FOIL out that numerator. That looks like that's 2 binomials being multiplied. So you want to multiply stuff out when you need to. So what I'm going to do on this one is start by multiplying this stuff out. Let's see. There's something, though, that I see. There's something I see. You want to look for stuff. I always kind of pause on these a little bit and see if I see something. Here's what I see. If I let the tangent be sine over cosine, then that would simplify something a little bit, okay? Now I'm going to just kind of show you this you can kind of do stuff like this in your head. If you had cosine x times sine x over cosine x, well, then you would just end up with sine x, right? Okay, and it's probably best to start this problem this way. If we didn't do it that way, we'd do it later anyway. So anyway, you would end up having sine x plus 1 times sine x minus 1. Okay, and if you see something simple like that, you can do that in your head. So that gives you that. And then that's going to be all over cosine squared x like that. Okay, now you probably want to FOIL it, but now you've got a difference of two squares, so you can take that shortcut on this if you want to. You can either go through all 4 steps of FOIL, or you can just go through the 2 steps, because what happens on this, as we've seen this before, is the inner term and outer, they cancel out anyway. That's sine minus sine, so you don't have to worry about that. Okay, so what you would get is if you do sine times sine, that's going to be sine squared x. 1 times 1 is minus 1 over cosine squared x like that. Okay? And again, there's more than one thing you can do with these problems. That's so what I would see on this one is when you see sine squared or cosine squared popping up, then the thought is, let's see what we can do with this Pythagorean identity. And there's really more than one way you could do this problem then. This is what I would be inclined to do is this, and I'm just going to write this at the side over here. So if you have the identity sine squared x plus cosine squared x equals 1, well, there's a couple of things we can do. One thing that we could do is this. You can rearrange these identities in your head. Now, since I have a sine squared x minus 1, my thought would be, let's rearrange that. Let's move the 1 there and the cosine there. Okay, so what I'd end up getting is sine squared x minus 1 equals negative cosine squared x. So anyway, what I'm going to do, see, is the sine squared x minus 1 is just this. So you can rearrange identities. And by the way, you don't have to do it the way I did it. I can think of several other ways I could have done this problem. This is just what I'm thinking is I can rearrange that numerator. So now what I get is I get negative cosine squared x over cosine squared x. So what's the answer to this problem? Negative 1. Okay. Now this kind of stuff takes practice too. I mean, sometimes you end up when you're kind of a beginner at this, you do this sort of in a complicated way. You start learning to look for stuff. Okay, that's kind of what you gain over time is you'll get to that point then. Okay, you guys see what I did on that? Okay, so again, I just kind of simplified, FOILed, and what you learned when you see a sine squared pop up, you should immediately go to that Pythagorean identity. It's always going to have something to do with that. Okay, this next one, now this probably has a lot to do with factoring more than likely on this one. So figuring out how to work with this one, what I would be inclined to do would be to factor that numerator. And by the way, sometimes I play with these problems and I end up going in the wrong direction the first time. And if I do, I just try something else. So you have to kind of try ideas that you have. So first of all, before I factor that numerator, I want to remind you of a couple of things. Like if you had x to the 4th minus y to the 2nd, that's a difference of 2 squares. That's no different than having something like, even if you had something like x squared minus 16, okay? And we did this earlier in the semester. This popped up a lot. That's the one where you go x plus 4, x minus 4. That's a difference of 2 squares. So if you were to factor this, it would go like this. This is a difference of 2 squares. You would say x squared and x squared to get x to the 4th. You would say y and y to get y squared. Then you'd say plus and minus. So this sine to the 4th x minus sine squared x is a difference of 2 squares. So my thought is I'm going to try to just factor this and see what happens. I don't really know where this one's going, but as the problem unfolds, I'll begin to know. So what I want to do here is we'll write this as sine to the 2nd x in the first parenthesis, and then sine squared x in the second. And then we'll do sine x. Now I have another idea. Okay, and see, this is what happens to me, and it'll happen to you too. Okay, and that's what I just was telling you. Sometimes my initial thought is not the best one. I have a better thought. Okay, I don't know if you guys know what I'm talking about or not. Okay, whenever you factor something, the first thing you always look for is a common factor. Does that have a common factor? Yeah, that's the best way to do this problem. I think the other way, I would have just started going in circles with it. Okay, so let's do that. Okay, so let's take a sine squared out. Okay, and then if we do that, we would have in the second parenthesis, we'd have a sine squared x minus 1. And then I've got a secant x like that. That's a better approach to this problem. I just immediately saw the difference of two squares and thought that might work, but now it's not going to get you anywhere. Okay, all right. So like the last problem, the thing that we have on this is probably has something to do with this Pythagorean identity. So a couple of things that you could do on here then is, and you can kind of do the little scratch work, on scratch paper, just kind of at the side. So what I'm going to do is I'm going to do this. This is my thought is, since this is a sine squared x minus 1, I can do exactly the same thing I did on the last problem. I can move the 1 there and the cosine there, so that rearranges to give sine squared x minus 1 equals negative cosine squared x like that. Okay, that would be my thought on how to do that. So what I'm going to do is replace sine squared x minus 1 with negative cosine squared x, and then just kind of see where this leads me next. So let's do that. Let's change this to sine squared x, and change that to negative cosine squared x, and then it's all over secant x. Okay, so let's do that. Now the secant, what you can do with this is this. Remember, a secant of x is really 1 over cosine of x, or you can look at it this way. 1 over secant is cosine. So if you look at this right now, I have 1 over secant in this problem, right? So I can replace that 1 over secant with cosine, and that would just go to the numerator of that fraction. So if you think of that part, then you would end up having this. You would have sine squared x times negative cosine squared x, and then you would have times cosine x like that. Now this is going to be an example of a problem that probably isn't going to simplify too far. One thing that you want to try to learn how to do is to get these things down to one trig function though. Okay, so that's what I'm going to do on this, is do this. So just a couple of more steps, and then this one isn't going to simplify too far. So what I'm going to do is I'm going to change this, and you want to learn to do this in your head, okay, because you'll do this all the time in higher now. Okay, that sine squared, you just move the cosine the other side, so that would be sine squared is 1 minus cosine squared. Okay, just rearrange these identities in your head. Okay, so basically what I'm saying is sine squared is 1 minus cosine squared. So I'm going to make that replacement there, and then these two things multiply out to give negative cosine to the third x, and then I'm just going to multiply it out. Okay, all right, that's about all I see on this problem is that. You mainly want to try to get these things down to one trig function. So now if I multiply out, I would have negative cosine to the third x, and then a negative times a negative would be positive. 3 and 2 add up to 5. So that's probably about as good as you can get that. Okay? Sometimes they simplify to real nice simple answers. Sometimes there's a little bit more involved in that. Okay, so that's kind of the approach that you could take on that one. You might be able to do that in a little bit different direction on that problem. Okay, so that one's a little tricky. Okay, you guys have any questions? What I'm doing? Okay. Mainly what you're going to do in this section is verifying identities, and verifying identities introduces students to a little bit of an idea of what mathematical proof is, although this is not really a proof. It's more of a verification process on this. But it also gives you skill in what we just did here. It gives you skill in rearranging trig expressions using identities. So on this next page, what we're gonna do, the rest of the section that we'll look at is we're just gonna do, I think our textbook Some textbooks say prove the identity. Some say verify. I think our textbook says establish the identity, okay? Which just means you're going to show that one side is the same as the other side. The first thing I want to emphasize, and this is real important, students oftentimes are just kind of a beginner at this kind of thing here, and the proofs are a little chaotic. You don't want your proofs to be chaotic. You want them to be straightforward. So this is what the way I want your proof to look like is like this. You just pick a side and you write it down. Okay, that's the first step is always the same. You usually pick the most complicated side, write it down, and then see you only work with that expression, and eventually you should end up with the other side. Okay, and I'm not going to go through this proof. The purpose of this proof is to show you this is what it needs to look like. And a lot of times when I do tests and stuff, students' work is chaotic. Okay, I can't handle chaos. I can handle this. I can quickly go through and check your logic on that and see that it's right. So don't do your proofs any other way. Write a side. Notice how those equal signs keep coming down. And eventually, if all the logic's correct, you'll end up with the other side. Okay, and when I'm doing these, that's exactly the way that I'm going to do that. Okay, so refer to that as kind of a guideline on how these proofs need to look. Okay, so we're going to work with some of these, and sometimes they're very simple. Sometimes they're a little bit complicated. It's common that you sometimes try something and it doesn't work. And if it doesn't work, you try again. Okay, there's a little bit of trial and error in learning how to do these problems. There really is. Okay, so here's how I want you to do a problem like this. So we're just going to establish the identity. You can put the word proof on there or you don't have to. So pick the most complicated side. The most complicated side is the thing that has the most stuff, or it has fractions and stuff like that. Clearly, to me, on this one, the most complicated side is the left side. Now, these problems are kind of like puzzles. They're fun. I remember this is what got me into math in college. I had no idea I'd major in math. I mean, when I took trigonometry, we learned these proofs, and I got so into it that I did like every problem in the book. I was just fascinated with it. And that's kind of what ultimately got me kind of turned on to math early on in my college career, was these kind of problems. So what I'm going to do is I'm just going to work with this and see kind of where this leads me. And there's more than one way to do this. My thought initially on this is just do the distributive property. So we'll have cosine theta times tangent theta plus cosine theta times cotangent theta there. Now what we're going to do is we're only going to work with this. You don't need to write anything on the left side of that equal sign anymore. We're going to work with this. We're just going to look at our identities, and we're going to try ideas. Okay, so my idea would be a tangent is a sine over a cosine. And the other thought I would have is the cotangent is a cosine over a sine. So I'm going to do that replacement. What you basically do is just substitute, make substitutions. Hopefully you end up ultimately with the cosecant on this problem. So if we do this, we would get cosine theta times sine theta over cosine theta. That's kind of working nice. Then over here we have cosine theta, and then the cotangent is cosine theta over sine theta like this. Okay, so let's see. That will cross out the cosines. That will leave us with sine of theta. And on this side, this part right here, cosine times cosine is cosine squared theta over sine theta like that. Okay, well, okay, I'm not there yet, but I'm making progress. Okay, so the only thing I could probably think to do here would be, well, you're going to have to get a common denominator. I mean, your answer needs to be a cosecant of theta. So the next thought is, let's just introduce a common denominator and see where it leads us. Okay, and this one, what you do is you just need, the common denominator is sine, so that means you need to multiply this fraction by sine theta over sine theta like that. Okay, now I see where this is going. Sometimes it'll kind of reveal itself later in the proof how it's working. So now what I get is this part right here is sine squared theta over sine theta. And then the second part is cosine squared theta over sine theta like that. Okay, and again, I keep bringing the equal sign down, and I keep putting this together. All right, so what I get is, probably should have given you guys a little bit more room, I get sine squared theta plus cosine squared theta over sine theta. Okay, so we've now got the fractions put back together like that then. Okay, all right, you guys with me so far, what I've done? Okay, what's next? What is sine squared plus cosine squared? That's 1. That's an identity, right? So we end up getting 1 over sine theta. What's 1 over sine theta? See, it works. Okay, that's what we're trying to prove. Okay, and that's why you need to do that, is eventually it should work its way out and give you that, get you to that right side. Okay, that's the idea. You got to show those steps. Another thing is that's a real bad thing I see students do all the time is they forget if they don't write their sine or the theta. Okay, you can't leave that theta off. It's an important part of the problem. Okay, I always say if you a sine theta with a sine without a theta is a sin. That's what I say. Okay, so leave that theta on there. That's important. Okay, I mark off for stuff like that. It's just kind of a thing that it's a little lazy on there. Just keep writing that theta when you do that then. Okay. All right, let me do this next one here. I'm going to do this kind of at the side here. You may have to kind of squeeze this in. Sometimes these proofs are 2 steps. Sometimes they're more. It just kind of depends. Okay, so the way I would do this is I, again, would start with the left side, write an equal sign. And you don't want to start these proofs any other way, and you don't want to work with both sides. You want to work with that one side until 1 pops out, okay? So my thought on this one would be, and I actually have 2 thoughts. I think most students would probably think, oh, let's just do distributive property, which is totally fine if you want to do that. But here's what I have. Here's my thought. 1 plus tangent squared is secant squared. Just plug it in, okay? Okay, and sometimes you're going to do these problems and you'll find a super easy way. Sometimes you might find a more complicated way. There's many ways to do the verification. So what I'm going to do is just write on the right side, I'm going to keep the cosine squared where it is. And then I'm going to change the 1 plus tangent squared to secant squared theta, like that. And then you can do this. You could actually, that's 1. If you multiply a cosine down to secant, you get 1, by the way. I'm going to write one more step because students don't always see that. What I'm going to do is change the secant to 1 over cosine. Okay, I just use the square. So what happens is that crosses out. Then you get 1. I'll say that's an example of a real simple proof. Sometimes you can get them done in 2 steps and you got it made. Okay. All right. So that sometimes they work their way out pretty easily. That one probably would have worked in another way too. All right. Let's see kind of what we're getting to in this next one here. So the basic idea on this one is, again, you want to start clearly with the left side. So just write that out. We have secant theta over cosecant theta plus sine theta over cosine theta, and then an equal sign. Don't write the right side, okay? That's what you're trying to prove anyway. So let me pause and let me kind of think about this for a few minutes here. Okay, now again, this takes some practice. I see how it goes already with a couple of steps. You may too, I don't know. All right, here's kind of what I would think. Do you know what sine over cosine is? Tangent. Okay, that's cool. We're trying to prove 2 tangents. How about this secant over cosecant? Well, what you can do, you could actually if you move the secant to the bottom, it becomes a cosine. If you move the cosecant to the top, it becomes a sine. Now, you could do this in your head if you understand that, okay? Or you could do this like this, okay? You could write that secant as 1 over cosine if you want, and you could write the cosecant as 1 over sine, and then we could change sine over cosine to tangent. You actually don't have to write that step, because what this turns out to be anyway is, and I'm going to just do this on scratch paper. You don't have to show this in your proof. 1 over cosine theta divided by 1 over sine theta is basically 1 over cosine theta times sine theta. So that's tangent theta. That's what that is. Okay. Now, what you guys want to learn how to do, and see, you can do this. You can, if you saw secant theta over cosecant theta, you can immediately change that like this. Okay. If you bring that to the bottom, it becomes a cosine. If you bring the cosecant to the top, it becomes a sine. You can do it that way if you understand that. Okay. So you would end up getting basically a tangent theta plus a tangent theta, and that's equal to 2 tangent theta. Okay, now what I did is I kind of looked at it for a few minutes. The first thing that popped out in my head was sine over cosine is tangent, and I'm trying to get a tangent is what I'm trying to ultimately prove anyway. That's how I knew to do that problem, okay? You could even on this problem, you could bypass that first step. I don't care. If you went straight there, that's fine, okay? Because you can do basic things like that in your head, okay? Okay, so let's see. So again, there's more than one way to do these problems. I usually just try to think about it a little bit and see if I can find the easy way. Okay, this one right here, if you don't know a trick, it'll drive you crazy, drive you nuts. So I'm going to teach you the trick. And sometimes, like if I haven't taught trig in several semesters, I'd be coming to class and I'd be going in circles on this because I don't think about the easy way to do this. This problem's actually very easy to do. So actually, what we want to do is just pick a side. It doesn't matter which side you pick. I'm going to pick the left side. They're both, to me, equally complicated. So I'm just going to start with that side here. And let me show you how you think through this problem, okay? Here's the idea, this is the way I look at it. How do I really want that to become a secant. How could you make that become a secant? What is secant? It's 1 over cosine. Remember, you can divide each part of everything by the same thing. If you divided by the cosine, look what would happen. If I did cosine divided by cosine, I'd get 1. If I did 1 divided by cosine, I'd get secant. Okay, this one will pop out in like 2 steps if you do it this way. So this is what you want to do. You want to just do this. You want to take each term and divide by the cosine. And again, if you don't know this trick on this problem, you would just go in circles and it'd drive you crazy. You'd never get it probably. So we're going to do that, and we're going to do exactly the same thing to the denominator. So I'm going to divide by cosine like that. Just make sure that everything gets divided by the same thing. Okay, so what you're really doing is you're really multiplying the top and bottom by 1 over cosine. Okay, that's what you're doing. Okay, now you got it. Okay, so cosine over cosine is 1. 1 over cosine is secant. And then the denominator works the same way. 1 over cosine is cosine, or 1. 1 over cosine is secant. Problem done. Okay. Look for stuff like that. Okay. Look for the fact that sometimes you can do algebra to something and get it to work out a little bit easier. Okay. Does that make sense? Okay. Now, usually if somebody's doesn't have experience with these problems, you wouldn't ever think to do that. But it's something to look for when you're doing a proof. Okay. All right, let's see what we're getting into on this one. So this one, it doesn't really probably matter which side. I'm going to go again with the left side. The thing on that is you could probably work with the right and get to the left, but it actually is probably a little bit easier maybe to go from the left to the right. I don't know. I'm getting ready to find out here, but let me think just for a second on this. Yeah, let's just go with it. Sometimes I don't know where it's going to lead. This is one that I'm not real sure how it's going to lead. So let's just start this way and roll with it and see what happens. So one thing that's kind of important is ultimately we're going to end up with sines and cosines. So what I'm going to do is I'm going to use 2 basic identities. I'm going to use the identity that the cosecant is 1 over sine. I'm going to use that. And then I'm going to use the identity that the cotangent is cosine over sine, and I'm just going to roll with it and see where it takes me. Okay, I'm getting ready to find out where it's going to take me. So this is going to be 1 over sine x, and then this is going to be minus cosine x over sine x like that. Okay, so I'm going to just try this and see where it gets me. Okay, all right, so now what I'm going to do is I have a common denominator. So by putting that together, I have a common denominator. So you could write this as 1 minus cosine x all over sine x like that. Well, okay, I'm not quite there. I mean, that's not the same. So we're going to have to do something else. Okay, so here's my thought. Now, and then again, these kind of things right here, until you gain experience, you're not always going to think to do. Here's the idea. I want the denominator to be 1 plus cosine. I want that to happen. So here's what I'm going to do. I'm going to, remember, you can multiply the top and bottom of a fraction by the same thing. I'm just going to multiply it by 1 plus cosine x, and I'm going to see what happens, okay? All right, so I know that I've now got that 1 plus cosine in there. And I'm kind of now beginning to see where this thing is going to work its way out now. Okay, so I'm going to multiply out the numerator. Now, you can do this in your head. Little simple things you can do on scratch paper, and they don't have to be a part of your proof. So this part right here is just going to be 1 minus cosine squared x. Okay, that's a difference of 2 squares, kind of when you multiply that out. So that numerator is going to be 1 minus cosine squared x over sine x times 1 plus cosine x like that. So I see where this is going now. Okay. Now let me ask you guys. Do you guys have any thought about what else I might want to do? I mean, I've got the 1 plus cosine. What I need is that sine in the numerator. Any thought about that 1 minus cosine squared x? Yeah. The Pythagorean identity, absolutely. Okay, again, you can do this as kind of scratch paper. So you have sine squared x plus cosine squared x equals 1. You can start doing stuff like this in your head. See, if I move the cosine over there, I get sine squared x equals 1 minus cosine squared x. Okay, so what I'm going to do is I'm going to replace 1 minus cosine squared with sine squared. Now it's going to work its way out. Okay, so now we're going to have sine squared x all over sine x times 1 plus cosine x. Now I'm almost there. What happens? Yeah, one of the signs crosses out. You have sine squared over sine. And again, you do this in your head. If you have a sine times a sine over a sine, 1 crosses out. So you end up getting what you wanted to get. You ended up getting sine x over 1 plus cosine x. I knew it would work. I wasn't sure how it was going to work. Now it's pretty clear to me. Okay, and I'm pretty sure that one probably could have worked the other way, going right to left, but I have a feeling it might have been a little bit more complicated. Okay, isn't this fun? God, I love this. This is just, I could do this all day. I could do this on the weekend just for entertainment. I'm bored. I just prove identities forever. Fun. Okay, I'm a geek. That's okay though, right? You might enjoy that. By the way, one thing on this, my math lab, when you do proofs on my math, it's not a good way to learn. So what I would always recommend you do when you're doing your homework, I think on the homework there's like 6 proofs or something like that. You know, do it on paper and then translate, because the way they do some of it is multiple choice. Which proof is right? And that's not a good way to learn how to do this. You just got to do it the old-fashioned way, okay? Okay, let's see. This one right here looks like a problem I just did. This one is, I don't know why I put this one in here because it's the same idea. I think this time, just for something different, I'm going to start with the right side. It's up to you which side you start with. So let's write down left side. Let me see if you guys have caught on to what I did a few minutes ago. This one is, if you don't know the trick, it'll drive you crazy. So any idea? It looks just like that problem I did a few minutes ago. Here's the way I look at this, is like this. I want the cotangent to turn into a 1. So I divide by cotangent. If I divide everything by cotangent, it works. See, cotangent over cotangent is 1. 1 over cotangent is tangent. Okay, so it's that same trick. Okay, and I know I put one of these in your homework, just kind of make sure you're paying attention to that. So again, you just do this. You just do cotangent theta plus 1, and you can just show this one step. This is the only step you have to show. You do have to show this step, because otherwise I wouldn't have a clue what you were doing. So we got that. And then the bottom we have cotangent theta minus 1. And then it works its way out. So then you end up getting 1 plus tangent theta. And then we end up getting 1 minus tangent theta like that. So the problem's done. Okay? That's how you would work that one out. All right, let's see. Let's run through. I wanted to do a few more of these things. I'm trying to just get as many different ideas on here as I can. This one, it's pretty clear that the left side is more complicated than the right side. So start there, just write it down. You do need to write that side down, and then write your equal sign. And then we'll start trying to figure out how to go with this one. Again, you just try ideas. Okay, you just sometimes you look at it and just roll with some idea that you have. Okay, let me see what you think. What do you think? Anything I can do with the tangent that would be a good idea? Yeah, sine over cosine's a good idea there. Okay, how about cosecant? Yeah, good idea. Okay, again, just try it. Don't overthink things. Just sometimes you just try things and see where it leads. So let's change the tangent to sine x over cosine x. Leave the cosine x alone because it's going to cross out. Okay, and then the next one we'll do 1 over sine x times sine squared x. So this is another example of one that's probably a real simple couple of step proof. Sometimes they work out that way. Okay, so let's see, that would cross out, and one of the signs would cross out. So what you would end up having then is you would just end up having sine x plus sine x. So that would be equal to 2 sine x. That one's a pretty easy one to do if you do it that way. Okay, all right. All right, let's do these last two and see what we're getting into here. Okay, generally we try to do the simpler ones and kind of mid-level verifications in this class. All right, so let's start on this one with the left side. Okay, now let's see. There's several approaches on these problems. I can think of a couple of approaches on this. Let me show you what I'm going to do first, and this is my thought. So again, one of the things I've been telling you is if a sine squared or a cosine square pops up, it's the Pythagorean identity is what you're probably going to use. Now, you could either get a common denominator and put it together that way, or you could do this. What I'm going to do is in my head, you can just do this. The sine squared theta is equal to 1 minus cosine squared theta. You want to be able to do that in your head very quickly and rearrange these basic identities in your head. So what I'm going to do is I'm going to replace this with 1 minus cosine squared theta. Okay, so I'm going to bring down the 1, then I'm going to change this to 1 minus cosine squared theta over 1 plus cosine theta like this. Okay, and then I'll kind of show you what my thought process is on this problem. Okay, well, what I know that I want to happen is I definitely want this get rid of this fraction because I'm just proving that it's equal to a cosine. Let me ask you this question. Do you have any idea what you could do with 1 minus cosine squared theta? I haven't done any problems that had factoring involved. Does that factor? Is that a difference of 2 squares, 1 and cosine? So you could go 1, 1, cosine, cosine, plus minus. That does factor. And it's very beneficial because when it factors, you're going to see what happens. Right? So change that 1 minus cosine, factor it. Don't forget that factoring is an important skill you can do. So you just go 1 and 1, cosine theta, plus, and then 1 minus cosine theta. Okay, and it would be all over 1 plus cosine theta. Why is that a good idea? Okay, because that crosses out. And that's what I saw, and you'll start seeing stuff like this as you gain experience. So what I end up with is I have 1 minus parentheses, those parentheses are important, 1 minus cosine theta, like that. Okay, you can distribute that through, so you would get 1 minus 1 plus cosine theta. Well, that's cosine theta. Okay, that probably is about the simplest way you could do that. There's other ways that you could have got that, but that would be kind of my thought on that, would be to do that like that. Okay. All right, don't forget about factoring. That'll show up occasionally as you're doing some of these, establishing some of the identities. Okay, this one, let's see. This one's kind of an interesting one. What I'm going to do on this one is start with the left-hand side, because it is a little bit more complicated. So we have secant theta minus cosine, or alpha, secant theta minus cosine alpha over secant alpha plus cosine alpha. Okay, now this is what I'm going to do on this is a good strategy a lot of times is to get everything written with cosines and sines. So what I'm going to do is I'm going to change this secant to 1 over cosine. So that's my initial thought. I'm going to leave the cosine alone because it's kind of beneficial to get this down to where it just has one trig function. Okay, so secant alpha would be 1 over cosine alpha. Then I'll bring down the cosine alpha. And then the bottom I'll have secant alpha is 1 over cosine alpha plus cosine alpha like that. Okay. Now, the other thing is, this is what we call a complex fraction. You've encountered complex fractions throughout the semester. So my thought would be, I don't want that fraction to be there. So how can I make that cosine in the denominator go away? I can multiply by cosine, right? So I can multiply the numerator by cosine alpha. I'm going to put that as cosine alpha over 1, and you have no choice but to do exactly the same thing to the denominator. So let's try that, and let's see if it takes us anywhere in this problem. All right, so let's see. You want to try to do as much of this as you can in your head. Okay, when I do a distributive property, I'll end up getting cosine alpha over cosine alpha. Then I'll have minus cosine squared alpha. Similar thing happens in the bottom. I do a distributive property, I'm going to have cosine alpha over cosine alpha, and then minus cosine squared alpha like that. Okay, so I've got that. So let's see where this is leading us then. Oh, thank you. I just saw that. All right, so no. The top one's minus. It's the bottom one that I made a mistake on. Okay, so now we got that. Well, okay, what we have left over is it looks like we have 1 minus cosine squared alpha over 1 plus cosine squared alpha. So when you start getting down towards the end of the proof, then start looking at what you're trying to prove. Well, we've got the 1 plus cosine squared alpha. What we don't have is the sine. There's one more step and you're done. What is 1 minus cosine squared? It's sine, okay? So that is the sine. So then that proof is done. Okay, like that. So that's it. Okay, and that'd be probably the simplest way to go about doing that problem. So probably a lot harder to go from right to left on that one then. Okay? All right. So these things, they challenge you a little bit, but they get you, this is one way to learn your identities real good, and ways to learn how to manipulate expressions. That's what this is all about. It's an exercise, and helps you to gain that skill, because you'll need that in Calc 1 and Calc 2 particularly. All right, any questions? Okay, have fun with this. This stuff's good. All right, so I think we'll stop there. The next section's super short. The next 2 sections we're going to do are real short, so we'll probably next week on Monday do the 6-5 and the 6-6, and then really